Thank you, George. Thank you for the introduction and to the ITF for the opportunity to share what we're doing on iRAP. So iRAP, it stands for the Accelerated and Intelligent Collection of RAP Attributes. Alex gave a bit of an introduction to iRAP before, but I'll go into a little bit more detail. So we know the problem is a very big one. It's a big one in terms of real numbers of how many fatalities are happening on a daily basis around the world. It's also a very big economic problem. The fatalities are estimated to cost us 1.7 billion US on an annual basis of global GDP. What we are only really beginning to understand is the scale of the severely injured. So we heard in the last presentation that severe injuries, or rather in the questions, that the severe injuries are a big focus for road safety. And this thing includes things like brain trauma and internal injury. So really things that are affecting people on a very long-term basis. And the cost of these is, again, really only coming to the fore that we understand the scale of it. And it's actually much bigger than the fatality cost on an annual basis. So the Sustainable Development Goals, obviously, road safety is a big focus of Sustainable Development Goal 3. The target 3.6 is to halve the number of road deaths and injuries by 2030. And so in order to actually get to that point, we've really got to scale up what we're currently doing in the road safety space to help achieve that. We know what's needed. We understand that it's around safe road user behaviours. We know that it's around safe vehicles and improving vehicle technologies. And we also understand that the infrastructure characteristics that play into road safety. But the challenge now is really how to implement this on the scale needed to achieve the SDG target. So what is iRAP? Just a quick snapshot. iRAP is the umbrella organisation for a whole range of regional and country road assessment programs. We inspect high-risk roads to develop star ratings. These star ratings feed into safer road investment plans that help governments at all levels target investment and know what safety treatments to install. We do a lot of capacity building work and sustain capability at different levels. Through our crash risk mapping, we track road safety performance over time, drawing on crash data where it's available, and we really advocate for safer road policies and planning, and specifically safer road designs and that investment. Star ratings are linked to two road safety targets. So the first one, road safety target 3, is that all new roads achieve a minimum of 3 stars by 2030. And target 4 is that 75% of travel on existing roads is on roads that meet that 3-star standard. So we've had quite a bit of impact. iRAP really came about, it started in Europe, but about 10 years ago now, or it's rather, sorry, 20 years ago now. And in that time, we've reached over 100 countries. We've star rated over 1 million kilometres of roads, and we've influenced over $75 billion worth of investment. We work with a whole range of organisations and have very robust partnerships that have lasted many years with many of these organisations. What all that work has given us is a really interesting snapshot of what the world's roads look like currently. In each of these pie charts, you'll see the different colours for the different stars. They're very tiny, so I'll explain it. The black is the 1 star, so they're the very unsafe roads. Red is 2-star, and it goes up to green, 5-star being the safest. And we can see for pedestrians that the very large majority of roads are only 1 and 2-star. And this is for roads that are where pedestrians are present and speeds are over 40 kilometres an hour. And the picture looks very similar for bicyclists as well. Motorcycles are slightly better, about 1/3 are over that 3-star or better mark, and for vehicle occupants, it gets up to about the 2/3 range. So in terms of the economic benefit of improving roads and lifting that star rating, we know that the cost of road crashes, so that they're those fatality and serious injury costs, halve for every incremental increase in star rating. So if you think about those original numbers that I showed you of the annual cost of road crashes, and think about how we can, if we can move towards 5-star roads, just what the economic benefit globally would be. And of course, the many, many lives saved and unaffected by preventable road crashes. So just to show you in action what we look at. So we look at a whole range of different attributes. There's about 50 different attributes, and there's a number of sub-attributes under each one of these. But we look at things like roadsides, intersections, road surface, things like lane width and number of lanes. We look at median and that risk of head-on collisions, and other things like street lighting and rumble strips, and other factors such as curvature. So our model is, as you can see, is driven off the road attributes, and each of those road attributes are given an associated risk factor, which is based on research and evidence. And that produces our star rating. From the star rating, a safer road investment plan is produced, and that really gets driven off the treatments that, again, are supported by that research and evidence. And from there, we end up with a benefit cost ratio of those safety measures. So we can say, put that equation of the value of human life and the cost of these treatments together and produce an investment plan. And then that also drives the fatality and serious injury estimation, so we can track the reduction of that over time. We have a range of specifications which support the collection of this. And so I guess the really important thing is that globally, these remain constant. So these are the global standard for how this data is collected in such a way that we know that it's accurate, and it is the data that is based on the research and evidence that underpins the model. And all of this is documented in our fact sheets that are available on our website as well. So this brings me to iRAP and what we're trying to achieve. Traditionally, we have manually collected data. So what we normally do is take video data of the road. We send that video data off to a team of people sitting in a room in front of lots and lots of monitors, and then they record each of those attributes I showed you earlier manually. And obviously this is quite a time-consuming exercise. It tends to be a bit expensive as well, and it can also be open to human error, and also limitations of data collection. And we really see this in our supporting data collection, which covers operating speeds of vehicles, for example, or pedestrian flows or vehicle volumes, where it can be harder to get our hands on that data and accurate data. So the concept is that, as Alex touched on earlier, there is a lot of data becoming available from current and emerging sources, and how we channel that into producing RAP attributes. And so iRAP is really about capturing those things, but it's also about managing that global specification and the quality of that, to ensure that when we are pulling data from various sources, that this meets our specification and does so consistently. And it's going to be very important when we're potentially pulling the same attribute from two entirely different types of source data. So what we expect is not to have everything sort of sitting on a cloud and ready to download and use, particularly initially. I think what we are expecting will happen will be, there'll be a whole range of different types of data come available and be able to produce attributes. Some of this will be readily available, and just due to the conversion exercise, it will be able to be easily and cost effectively converted with a minimal compute, and so therefore it will probably be readily available anytime anyone needs it. but in realistically, we are expecting that there'll be more sort of compute on demand where we have, say, feature recognition, which takes a much higher exercise to convert this, and the cost as well is a bit higher. So it's really about finding where data is available, and then when it's needed as iRAP attributes, that then it gets converted across. And we're also accommodating for a third type of data as well, which will be the collect and compute on demand. So this is where, say, for example, feature recognition cameras get run around roads, and then the attributes are automatically pulled from that data. So this just shows the conventional methods of what we're currently doing and how we manage the quality assurance, which is really around all our global specifications on how to do surveys, how to collect the supporting data and the coding in order to produce RAP attributes. And what we're looking to move to now with the iRAP method, which is capturing the potential of that source data to get converted into algorithms and validating that, making sure it works for different road types and in different geographic locations, for instance, and then producing those iRAP attributes. And so the important distinction here is that iRAP itself is not looking to produce the source data and do these conversions. We're really about trying to support those out there with this data, and by providing a place where this data can be made available to end users and people who need it. So where are we now, and where are we looking to go? At the moment, we are working on basically a whole range of single and connected attributes. From this, we have the potential to start producing simple road safety KPIs. These are things that can be picked up, such as speed of vehicles, volume, traffic volumes, and whether there are pedestrian facilities, for instance, or where roads are divided and undivided, and again, those speeds. As we go along, and even now, we're starting to see the potential for groups of critical attributes to emerge. And as I mentioned, we are going to be providing a sort of data marketplace which enables this data to be provided for end users to access via that marketplace. And then once we've had those groups of critical attributes, it makes it really possible to start producing LightStar ratings and fatality and serious injury estimates from that data. And this really brings us to sort of our first aim, or our initial aim, I should say, which is really about accessible large-scale data to enable more efficient and accurate star rating assessments and risk mapping. And then we're going to get to a place where all attributes are going to become available. And I think this realistically will be within 2 to 5 years, so by the middle of the decade, which will enable full star ratings and fatality and estimation, fatality and serious injury prediction to happen. And we're already working in a space where this will be, in some cases, integrated into asset management systems, which then makes routine and seamless star ratings of road networks realistic, and they become an integral part of roads authority operations. Then we're foreseeing the next big step is going to be really this integrated and systemic star ratings, partly driven off the integration into asset management systems, which we're seeing a big demand for. And from there, we move into a space where we can have those safe road investment plans produced off the back of the full star ratings. We are able to then optimize that investment and get that integration into insurance systems, and really start unlocking that investment based on those costs that I showed you upfront, to say this is a point where we can really understand the cost of what these road crashes, and then connect the business case for building safer roads. This will also drive things like route mapping and navigation to help people choose the safest networks to travel on. And then beyond that, dynamic real-time star ratings are going to be possible at some point. So this is star ratings which may be varying on time of day, whether it's nighttime or daytime. And this is really connected through to the real-time collection of data through vehicle connectivity. And then what we see is the potential for this to be influencing road user behaviour in real time. So whether that be people being able to choose the route that they take based on safest choice, or whether that is vehicle feedback either to the driver of a vehicle or to an assisted vehicle on you need to, like, on the speed they're doing, that you need to reduce your speed given the star rating of this road. So that's sort of, I guess, in a nutshell, where we are thinking of where all of this is going to go. It's a very big picture and a very complex picture. But yeah, more than happy to answer questions after this. Thank you.